In this video, we're going to unpack what's really inside the 74HC595 shift register. Instead of just using the chip, we'll rebuild its internal logic with individual components, like D flip-flops, and show exactly how it handles serial to parallel conversion. The heart of the 74HC595 is an 8-bit shift register made up of 8 D-type flip-flops. Each one stores a single bit of data, and they are wired in a chain, so on every clock pulse, each bit moves to the next flip-flop. In my model, I made a 4-bit shift register using 4 SN74HC595 chips. Now let's look at how a single flip-flop works. When a clock receives a rising edge, the D input value is copied to the Q output. The old value is shifted down the chain. So with each clock pulse, the entire bit sequence shifts one place. For example, if we send the binary number 1100, we set the data line to 1 or 0, then pulse the clock. Bit by bit, the value enters the register and shifts through all 4 flip-flops. But the 74HC595 doesn't just expose these values immediately. It is the second row flip-flops, which are output latches. These flip-flops only update when you pulse the latch pin, or latch button. For a clean clock and latch pulses using a 555 timer in monostable mode, each button press sends a reliable pulse to shift the register by 1 step or latch the data 1 time. This design prevents flickering while data is shifting. We clock in all the bits behind the scenes, then pulse the latch to instantly update all outputs in sync. There's also a clear button that resets all flip-flops to 0 at once. This acts immediately with no clock needed, and it helps initialize or reset the entire register quickly. And that's the core of the 74HC595, with 4 flip-flops chained together, a latch for synchronized output, and a simple interface of data, clock, latch, and reset buttons, all working together to turn serial input into a stable parallel output. This remake helps us understand exactly what happens inside the chip and how much digital logic is packed into a tiny IC like the 74HC595. Hope this helped you see the magic behind the shift registers.